I'm going to go pretty fast because you guys were supposed to try these last night. Something just went wrong. Something just went wrong. So let's figure out what do you need in number 1? U. As soon as you find a U, what are you supposed to do? Literally, do it. D. Solve for that dx. Don't take shortcuts. When you go to plug in, you do have cosine of u, but you have du over 3. Hopefully at that point you know the integral of cosine is negative sine, which leads us to the only proper answers. Oh, duh. No. Sorry, my brain is fuzzy. What is the integral of cosine? Positive sine. I'm sorry, I was taking a positive sine. So easy to miss. A lot of you guys missed this on your forever quiz. The integral of cosine is positive sine. The integral of sine is negative cosine. I apologize. P.S. Why would I make sure to pass out your forever requests today if some people are going to be gone tomorrow? What am I thinking? Forever final on Tuesday. You've been quoting, some of you have been handwriting. Hopefully you learned which way your brain internalizes, memorizes the cards best. That forever final is on Tuesday. It's very important, not just because it's a grade in your final exam category that's going to balance or cushion your final exam a little bit. It could bring it down a little bit for your final exam. Hopefully not. Hopefully it could bring your final exam up a little bit. But that forever final on Tuesday, look over the forever quest, see what you missed. Okay, then we're going down to number 5. Kiddos, to be honest, this is more of a BC question. It's not impossible for AB, but it is more of a BC question. Quick heads up, as a note, whenever outline first thing to always try whenever ln is inside an integral is let u equal ln, because there is no integration rule for the integral of ln. There are lots of rules where the integral equals ln of something, but there is no rule for the integral of ln. Some of you might not have known to do that, but if you let u equal ln, maybe some of you can see how that will make things much nicer. Because when we go to plug in, what happens to those x's? They cancel. The integral of u is 1. I'm getting back my x bounds since they are x's. And it's time to plug and chug, and you guys know how to do that. So do that carefully. Cancels 3 squared is 9. Minus 1 squared. Does it see? Okay. Look at number 7, check this out. If you solve number 7 the way that we have talked about in the past, and you try to split up like this, this is only possible to solve with BC techniques. But if you said instead, wait a minute, what can I do to the denominator? Oh my goodness. Life just got a whole lot better. So I should have solved it. This was a really good thought process, but it's impossible to keep going without BC. But if you use algebra techniques to simplify, then life got a lot easier. How does that look? Not too bad. You guys help me out on number 9. What'd you do? This one was hard.
You took the EX and you take the square out of it.
Good. You can rewrite this. You can see the ED of the x is being squared because it's 2. Guys, what integral is 1 plus u squared? Arctangent, you got it. Help me out. What do you do with this one?
I think you combine them. I think I said x minus 3 to the power of 1/2 and then combine the 2.
It's illegal though, we can't combine.
Rainbow rule, I think. X minus 3.
Exactly. This is an integration on track 1.
Then you solve for n.
And you can plug in for x, plug in e plus 3. Now I can legally combine. How do we solve this, guys?
Just take that roll.
Where'd you get 2 5 hash from?
Remember you have to add 1.
Wouldn't that be 3 halves?
No, you do 3 halves plus 1
Oh, you had
plus
3
2
halves.
over 2. Yeah. And 1/2 plus 1 is 3 halves. Now, do you guys remember how the AP likes to simplify these? They say there's some people in common. And not just that, they say we can make common denominators. Now technically, if you were sticking it to the man, you could stop, but this would not be an F or Q question, it would be multiple choice. So at this point, you would want to get, what, 15ths? So I'd multiply by 3 and Q. Multiply by 5. What goes into 50? Just 2. Minus 9 plus 28. 16. Does that match matchups? Anybody have that one?
They left it as it was.
Really?
Yeah.
They were not preparing you for multiple choice. We should see. Which one? Let's see what I've gone to.
Oh, I'm sure here. So I was confused on where you do the X because I subbed the index on top of it.
Oh, yeah. For 13, there are multiple ways of doing it. Anybody tell me the way you did? There are two different ways of it. Did anybody figure it out? Separate the sign, yeah, we could do.
You change the sign back to -1.
We could have done this. We could have done that. And then du. Do you guys see what's going to happen to the cosine? So if you want to use u sub, you could have gone that way. You've ended up with the integral, cosines cancel, u to the -2 du.
Do we not get rid of U prime? Oh, just one. Never mind.
Or you could have seen that this cosecant cotangent, something special. After doing u sub, you would get negative cosecant of x minus 1. That's one way of going. This way you would have gotten there too, because you would have gotten u to the -1 times a negative plus c, which equals -1 over sine. Kiddos, are these the same thing? They're the same thing. Found two very different ways. Both ways are good. Both ways are good. Alright, and what do we have? A couple more. This is very similar to the LN one. If you have something that you're not used to seeing in an integral, make it u. Who are you not used to seeing in an integral? Arcsine. So make it. Why? You guys tell me what's du. Exactly. Right? That is du, right? Isn't that what we're doing? And the u prime is just x prime, which is 1. So it's 1 over the square root of 1 minus u squared times, but u prime is just x prime, which is 1. Does that make sense? So then dx is equal to. Can you plug it in?
It's like murder.
Yeah. Are these just going to cancel out?
Get rid of things.
Now what's the dilemma at this point?
Oh, we have the two of them, A, B, and A.
You don't need the plus c because we're going to go. Unit circle.
Easy. They can all memorize.
Exactly. That is another joking pattern. When is sine square root of 2 over 2? Pi over 4. Good. At 45s. when is sine 0? 0. So you get pi squared over 16 times 2 is pi squared over 32. Does that match up? Does anybody have the answer written down?
That's right.
That's right, yes.
I'm realizing that some of you guys are probably almost done. If not done, I apologize. I should have gone to let you guys get ahead. This is second to last. Second to last.
Really? What?
This is the one that some of you guys under FRQs lost so many points because you couldn't solve a differential.
What's That's it. Lily.
I'm coming back and coming down. How many more do we have? Do we have any? Okay. Hey guys, what does your gut tell you?
The thing we don't know, which is square root. Oh wait, we want to get rid of x so we could have like a sign to the negative one. Because it's not square.
Wouldn't you maybe think of the square root, right?
Yeah.
Denominator. I see an extra x. If you have an extra x and it doesn't look like an arc trig, because if it was arc trig, this would be u squared, and then you'd have to make u square root of x, and du is just not there. So maybe it's integration on crack. So we can go ahead and plug in 1 minus u on top, square root of u on the bottom. Du with a negative. What can I do? Heart method, split it up. 1 over square root of u is u to the negative 1/2. U over square root of u is u to the 1 minus 1/2, or u to the positive 1/2. Some of you might need to go back and look. When I split it up, 1 over square root of u minus u over square root of u, it simplifies to be that. Isn't that just power rule now? So now add 1/2. Sorry, add 1, I get u to the 1/2 times 2. Add 1/2, I get u to the 3/2 times 2/3. If you want, you could pull out u to the 1/2, and you would get 1 minus 1/3 u. I'm not sure if you want to do that. I'm just saying you could factor out square root of 1 minus x. Now it's a plug and chug. So plugging in 3/4, I get negative 2 times the square root of 1 minus 3/4 is 1/4. 1 minus 1/3 times 1 minus 3/4 is 1/4. Minus, plugging in 0. Minus a negative 2, which will be a plus 2. 1 minus 0 is just 1. 1 minus 1/3 times 1 minus 1 is, sorry, 1 minus 0. 1 minus 1/12. 11/12. Square root of 1 is just 1. 2 times 1 is just 2. 1 minus 1/3 is 2/3. Need 12s. So 2 times 2 is 4, 4, 5 times 4 is 16. Oh, I did that fast. That always scares me. Is that 5/12?
Yes.
Nice. There's a lot of fractions. Now, guys, there were some hard integrals in this packet. How many integrals did you actually take on the mock AP that you took?
2, 3.
By hand? Yeah, probably 5 or less, 5 or fewer. Why did I give you a packet of all kinds of tricky ones? Just in case 1 or 2 show up. Is the entire exam going to be tricky integrals? No. And I wanted you to see the tricky ones, just so you kind of have them in your head. Does that make sense? Okay. Once again, if it's a calculator portion of the exam and an integral comes up, are you even thinking about trying to solve it by hand? No. Heck to the no. Put it in your calculator. If you guys are ready to turn this packet in, go ahead and pass it back, pass it over, get it out of your life. I'll still take it by the end of the day though, because some of you were still finishing up because you were absent, etc. If you were absent, yeah, you had a little extension on it. Just write absent when you turn it in tomorrow. And let's go ahead and see what's going on with the next one. See if I can get down to the wall. No, that's not what I want.
Oh.
No, don't worry, that's not what I want. Alright. You guys start looking. I figured out that I actually need to name this something different so I know what's going on. I accidentally loaded something from DC. That's not going to help you guys.
Misty, are these actually supposed to be on the lines or like at the points?
Roughly.
So they're not supposed to be like at the points?
Remember slope fields exist at infinitely many points?
Yeah.
So technically, just because they might not be only on the points doesn't mean like there can be in between slashes. Does that make sense?
Yeah.
In a point that's close, that's approximate. What's going on? Sorry guys, everything's going slow. You guys are working, right? Alright.
3. These are all not dydx, so you need to convert them all to That's so tricky.
The network is just being really bad right now, so I'm just kind of.
When it says find this in terms of x and y, does that mean solve it and have x and y in your
I'm pretty sure it's this.
find x?
This is like
But that's what I
X and Y, right?
I know.
This.
That's what I'm sorry.
Whatever it happens. You separate all the y things one side of dy. That's what I'm guessing.
I found this bracelet that I made when I was like 7. So it's really random. I think I looked it up and I was like, I was super into making bracelets.
So if you want.
No, it took me like forever.
Like,
Forever.
Is x over absolute values.
What'd you guys match for number 1?
B.
How come?
Oh, because all the rest are fractions pretty much.
And then you just like plug in the points.
And if they were all fractions on the x and y axis, it wouldn't be.
Yeah, if you plug it in back, the only one that makes sense is if you think about it, what line does this seem to be?
Y equals X.
Y equals x, so when y equals x, what do the slopes look like? Zeros, right? So if you plug in y equals x, only these two, when you plug in y equals x, will the slope be 0. Then you can test points like, I don't know, 2, -1. And if you plug in -1, 2, this one says that it should be a negative slope, the one doesn't work. This one says it should be a positive slope. Good, good, good. Guys, already number 3?
Yeah.
These are y equals, not dy dx, so you're following the flow. Question, which one of these functions has a vertical asymptote at 0, the curve going like this?
I could.
Wait. 1 over x goes like this, doesn't it?
Yeah.
It goes like that. -1 over x will go flipped. Will go like that. What kind of function goes like this? An absolute value says you're allowed to go on the other side too. That's why there's an absolute value. Definitely not sine or cosine.
No.
The 1 over x, you gotta know your basic graphs, right? -1 over x, not that one. So E. Ellen. I'll give you guys a second because not all of you have thought about number 5. Number 5, question, can we work our way backwards?
Yeah.
Could we just take the derivative of each one and see which one it is?
Yeah.
Yeah, sure.
Although the problem is, there's a y in that. Couldn't you take the derivative and then plug in y and see if this works? See if you can substitute. So you want to take the derivatives, then you want to plug into this formula. Take the y and plug in, does it match? Take the y and plug in, does it match? Take the y and plug in, does it match?
Wait, that's we do like one of them.
Yeah, hold on. Google Drive isn't working for me, so I'm trying to log into my OneDrive. What I mean by that is update this derivative. then compare that with what this says it should be. Times y. Do these match?
Oh,
Okay, so do these match? No. Right? So then try 2 and try 3. Right, the way I can say no. Aaron, you were so awake. You just talked nonstop. Shush. I'm glad you're awake, but be productive. What do you guys think? Does number 2 work?
Yes.
Oh. I don't know. Did you kill a bunny? Did you do you right? None of them were. I think 2 and 3 both work, don't they?
Yeah, 2 works.
oh yeah, 2 words.
Don't kill a bunny, you have to do times u prime, which is exactly what this one says. If you do the same thing on 3, it's gonna work out as well. So remember, the derivative of e to the u is e to the u times u prime, and that's what the differential equation says. Take the original times 0.2. You would do number 3, it would work out the same. Number 7, another concepty one.
Pretty sure. Miss Karen too. How's Karen this day? She's doing good. Did she get over her cold?
And she's came out to visit. So they can be pretty busy. Like sightseeing and stuff. Went to Washington DC and whatnot. Like someone's streaming music because this network is so bad right now. Okay. Number 7. What conclusion did you guys come to?
T. I feel like it was 2E. So, let's say.
Perpendicular means what?
Negative reciprocal.
Their slopes are negative reciprocal. So first of all, couldn't have that one, right? This one's negative. That's not it. That's positive reciprocal. That one is negative.
One number. That was really easy to explain.
It's kind of weird, right? will produce a slope field means the slopes from the differential equation need to be opposite reciprocals to all the slopes. So all the sine values are going to be opposite reciprocals to what? Cosine? Secant? Cosecant? Cosecant is the reciprocal of sine.
So negative cosecant. So A.
So remember, sine gives you slopes, so you need something that will have the opposite reciprocal slopes. So just take the opposite reciprocal of sine, so 1 over sine times a negative is negative cosecant. Number 9 is a great question. And if you guys knew how to do number 9, know how to do number 9, you would have gotten at least, if you missed the points, 6 extra points in your FRQ. A lot of you dismiss this problem outright. How do we solve this differential equation? What's the first thing we do?
Multiply by dx.
Multiply by dx. If you guys could just follow that one direction. You should be able to ask yourself, who does not belong? Y minus 3. So where are they going to move them? They can divide. Get rid of them. So it'd be like the one over 11. Just rearrange it the first time. Whenever you're solving a differential equation, whenever you're trying to find a solution to a differential equation, especially if they give you a clue, separate, integrate, plug and chug, simplify. Separate, integrate, plug and chug, simplify. To prove this point, let me write something on the board real quick. Usually when I hand back from all KPs, I take time to show you guys the score range, how to get a 1, how to get a 2, how to get a 3, how to get a 4, how to get a 5. I want you guys to check out real quick composite scores in each of these categories. It's based on how students perform on the tests. They distribute the scores, distribute the scores based on student sample groups that have taken different parts of the questions with ones that are fitted. But almost always, if you can get above a 65, most of all, let's say if you can get above a 70. If you can get above 70 points, we'll have a 5 on any AP comments in a year. But usually it's somewhere in the 66, 67, 68 range. Some tend to spin down to 65 on really hard. Some of you guys that got 1s were like, oh, it's awful. But look at the range of 1s. How many points are in the 1s category?
34.
34. From 1 to 34. Technically 0. 34 points. That's a huge range. But look at the 2s. How many points are there? 6. That's small. Then it goes to 12. Then it goes to 11. Then it goes to, well, that one's huge again. Okay? They do not expect perfection on the AP. Some of you guys need to look at your multiple choice and FRQs and realize, okay, every FRQ is worth how many points? 9 points. I'm showing you this differential equation that some of you guys got no points on. It was worth 0, remember, 5, 6 points. Okay. If you were at a 2, 6 points could have gotten you, and if you were like at a 36, 6 points could have gotten you to a 3. That one FRQ, that one differential equation. Depending on where you were at 3, that one differential equation, 6 points could have gotten you to a 3. Now, if you're in a 1, 6 points might not have cut it, but if you found a couple of big mistakes, or if you're like, I could have gotten points in those FRQs and I just gave up, Or as you go through your test corrections, you're like, there are so many stupid mistakes, or I really didn't get it, but we've been reviewing and I'm starting to actually learn my parameters. Some of those that I should have had memorized for rules, I just didn't know, but now that I know it, I can get them. Guys, you can jump these categories. There's not that much room in between. If you can just get up into the high 30s-ish, and then get an extra FRQ, or get up into the 35, 40-ish, get another FRQ. Don't give up on points. They're there. They're there to be gotten for those that are willing to persevere. So what do you have to know? Your parameters. How to read a question. How to analyze a question and say, okay, does this involve derivatives? Well, limits, derivatives, or integrals. Think about your quantities. Am I given rates? Am I given original quantities? Am I given some sort of just solvent, like a derivative or an integral? Am I given like an area or volume that I have to fit into a disk or a washer or a cross section? Am I given a funny case, I have to think about absolute values or special trig rules or multi-types. The points are there to be gotten, just like you want to proceed. Tonight, I want you guys to keep working on odds. How many more odds are there? Play around with Schofield differential equations, up to that, evens are optional all the way up to the odds are for tomorrow. Bye guys.